it will be the same because that was it was. So both cases, the answer is same. Okay? Now, all right. Now let's assume T1 goes first, then goes T2. Okay? So they are operating in what we call serial order, T1 first, T2 second. So what is it? What will be the answer of the average? We just showed it already. So you got here 2, 4. So take the average of 2, 4. What is it?
3.
What do you think average of 2, 4 is? 2 plus 4 divided by 2.
3.
3. And what's the second average? What's the second average? Come on, guys. Also 3, because what happened after the first statements, the result for R is 2, 4, and result for S is also 2, 4. So the average is 2 plus 4. For R is also 3, and S is also 3. Okay? All right. Any questions? If no questions, let's look at the other way around. T2 goes first, then T1. What are the averages? What's the average in the first case? First T2 goes, this transaction goes first. When the transaction this goes first, what's the values in the database? Both have this value. Okay, so what's the average? It'd be 1.5.
1.5.
4.5?
1.5.
1.5. And the second average?
1.5.
1.5. Okay, so we just saw that if a transaction T1 goes first, then T2, we have this averages. And if they go like this, it's a different average. Now, let's look at something else. Okay, so these are what we call serial actions. First this transaction goes, then this goes. First this goes as a whole, then this goes as a whole. This goes as a whole, this goes as a whole. So they are both serial executions, okay? They are both serial executions, but the serial executions, but the answer in one serial execution is different from the other. Okay, so now we are going to do something a little different. Let's see. Okay, first of all, I just want you to look at the bottom of the page, and when one or more transactions are acting simultaneously. Okay, so here in this case, we saw this transaction is acting by itself, this transaction is acting by itself. Now over here, we said these two are acting together. So that means this acted first, then this acted, then this acted first, then this acted. So this is a question of what we call how these transactions are scheduled. So we have the idea of what we call no, it is not same. Okay, in T1, T2, the average is different because this was multiplied by 2, and in the other one, it was not multiplied. It cannot be same. Okay, it is not same. Just look at it. Okay, now, So the question is, we have to come to the idea of something called a schedule. So if you have more than one transaction acting simultaneously, first of all, you must understand that every transaction is made up of sequence of read-write state actions or statements, okay? Operations, you can call them, or action. That means each action of a transaction is ordered, okay? So the order of the transactions cannot be order of the actions of the transaction cannot be changed, okay? So here we said, let all actions of T1 happen first, then T2. Here we said T2 happen and then T1, okay? So these schedules are called serial schedules. So what's the definition of a schedule? A sequence of actions by a set of simultaneous transactions that preserves the order of the actions in each individual transaction. What is a serial schedule? A schedule where the actions of each transaction are executed consecutively without any interleaving actions from other transactions. So we just showed that. So here the actions are, let me write down the actions. If we do it here, the actions are, in the first case, the actions are S1, S2, oh, what the heck, where I'm writing? All right, here. S2, then we have S3, then we have S4. In the other case, second case, we had S3, S4, S1, S2. Okay. Now, another thing I have to tell you, if you have any question, don't wait for the end of the lecture. Ask me now. Anything, anytime, you can stop me and ask me, okay? All right. So what we said here, in this case, the actions of the transactions are first S1 in the T1, then S2 in the T1, then T2 both S3 and S4. So these actions are in the order they're supposed to be. S1 is supposed to be first, S2 should be second. This is first, this is second. Over here, we just have T2 first, S3, S4, S1, S2. Okay, this is S1, sorry about that, okay? Now these schedules are serial schedules, okay? A schedule where the actions of each transaction are executed consecutively without the action of any other transaction interleaving action, okay? A schedule where the action of each transaction execute consecutively without any interleaving action from other transactions, okay? Now, just for a minute, we're going to change this. Now we're going to talk about non-serial schedule. That means this doesn't go by S1, S2, S3, S4. Something can happen in between. S1 is going, transaction T1 is going, it does the first part, oh, it's not finished, but the other one starts. Okay? All right. So let's show you something called non-serial schedule. Okay? So non-serial schedule will be okay, here is non-serial, okay? We could start with S1. And really, to be a serial, it should be S2. But we are going to squeeze in here S3. Then we are going to put back S2. And then we are going to have S4. Okay. Now, the first question is this a legal schedule? A legal schedule is one, a schedule where the actions from a set of concurrent transactions could be interleaved, but the actions of individual transactions must be preserved in sequence. Okay, so let's see. So if we have a transaction 1, T1 should have, S1 should happen first, then S2. Is that order maintained or not? S1 is happening first, S2 is happening later. In the second transaction, S3 is happening first, S4 is happening later. So this is a legal non-serial schedule. Legal. Okay, let me show you illegal so that you know when there is something illegal. So this, let me call it legal, okay, by definition. So what is illegal? Okay, maybe you can help me with that, okay? We didn't spell it right here, okay. Let's make it. Oh, all right, okay. All right, what the heck? I'm going to spell it separately. Okay. Now, illegal will be what? Let's say we started with S1. Okay? Started with S1. Now, illegal will be what? Let's say we have S3, right? Then what we have? How it will be illegal? That won't be illegal. S4, S2, S3. Is this legal or illegal? Let me just explain to you why it's illegal. Okay, the first transaction has steps S1 and S2 actions. The next one has S3 and S4. Okay, so S1 and S2 are following in sequence, but S3 and S4 are not. S4 is first, S3 is next. Therefore, this schedule is illegal. Okay, but this schedule here is legal. We can show many other schedules which will be legal too. Let's give another example. Let's say we start with S3, then we have S1 squeeze in, then we have S2, then we have S4. Now this is legal. Why is legal? Because S3 happens first, then S4 happens. And then S1 happens first, S2 happens. Okay, so what happens is there are a lot of these illegal schedules here. So we don't have to consider them at all. But this is called a legal non-serial schedule. Okay? Legal non-serial schedule. Okay, so let's again examine this 1 minute. Why it is non-serial? Well, for it to be serial, first one transaction happens, then the next one. Either could be T1 first, then T2, or T2, then T2. So there, if you have two transactions, there are only two serial schedules. What are they? I'm sorry, two serial schedules, yes. What are the two serial schedules? Two serial schedules for two transactions? Two serial. Okay, what are they? I just told you.
Legal and illegal?
No, just legal. Two legal serial schedules. No. We didn't talk about. I'm talking of two legal, two serial schedules. That's all. I didn't mention the word legal or illegal there. Okay. So one is T1, T2. The other is T2,
T1.
Of course, serial schedule is always legal. Why serial schedule is always legal? Because first one transaction completes, then the next transaction completes. So the question of there's no interweaving, no interference. So the question of order change is not going to happen at all. Okay, Now, what about if I have 3 transactions? How many serial schedules are there? I got 3 transactions. T1, tell me fast. T2, T3. How many serial schedules there?
3.
Serial schedules. They are not 3. Come on, guys.
Like, what I don't understand is like, okay, you told us that there are serial schedules that, okay, we can, it has to be,
Hold your horses. Don't go talk.
okay.
Okay. Now, what is it? One line at a time. Say what you want to say. One line. I am asking that if I have 2 transactions, how many serial schedules are there? Well, there are only 2. Either first transaction happen once and the next will be T2, or T2 first and T1 second. That's the only 2 serial schedules. If I have 3, how many serial schedules are possible?
3.
No.
Is it possible to have 6?
More.
Remember anything permutation combination? You need permutation?
6?
No, it's not 9, Victor.
Factorials.
How many?
6?
27.
Ha!
Oh, wow.
Ha! Okay, guys, here, let me show you. Okay, listen, there are 3. Not, okay. I'm sorry, 3 times 2. Okay, not divided by 2. You made groups. That's wrong. Listen, we're not talking about groups. Okay, so what happens is you start with, okay, you start with T1, or you start with T2, or you start with T3. Okay, so this is, you choose one of these. Okay, 3 ways, and then of course you left 2, right? So you can have either choose next out of 2, right? You choose one and then choose the other one. So that's 2 ways, right? And then same thing here, 2 here, 2 here. So you got 6. So if you have here 2 and 3, so either use T1, T2, T3, or T1, T3, T2. So I'll write out here like 1 at least. So either you go with the T2, T3, or you can do T3, T2. Everybody understands? Okay, so either it is T1, T2, T3, or T1. Okay, same thing here. If you have T2, you have T1 and T3, so you could have T1, T3, or T3, T1. Here is 1 and 2, so you have T1, T2, or T2, T1. So there's 6. You remember permutation? If you got 3 holes to fill, and you got 3 things, first hole can be filled by any one of them, 3 ways. Second, once that is used, you only 2 left. That can be filled in 2 ways. Once you fill the second one, you can only fill the last one way because there's only 1 thing left. So 3 times 2 times 1, 6, okay? All right. So the other thing is, you may be thinking that they have to be in any order. No, because if they have to be in order, then T1, T2, 3 is only 1. No. Okay, when we say it's a serial schedule, that means one transaction happens completely, then the next one happens completely. One happens, next one happens, next one happens. Okay, so these are 6. Okay, what about if we have 4? If we got 4 here, then how many ways?
It's going to be 4 factorial.
Okay, if you have 4, right? you got T1, T2, T3, T4. Again, like I said before, it'd be the same like for 4 factorial, right? Because you got 4 times 3 times 2 times 1. Okay? Now you got 24, whatever, who's ever said that. So this is only 6. And over here is, okay. So these are serial schedules, serial. That means one transaction happened first, then next, then next, then next. Okay. So the idea here is that serial schedules, they won't give the performance we need because they are not allowing any concurrence operation. You can see that. If first one transaction happens, then the next one, this one and that one, there's no concurrency at all. So we get nothing in terms of performance, very poor performance from the database. Databases execute thousands of transactions per second. If they had to just worry about only serial schedule like this, it won't work. Okay? So this is why what we happen is we look for ways to see how you can take a non-serial legal schedule, this right here, non-legal serial schedule. And we are looking for special non-serious legal schedules. We are looking for those schedules whose performance will be equivalent to, or the result will be equivalent to some serial schedule. That's what we are looking for. Okay? So that's the whole idea, is to take a non-serial schedule and see which are the serial schedules which are equivalent to action is equivalent to a serial schedule. Okay, that's what we are looking for. All right. So in the database, there is a big piece of software. This is actually the most complicated piece of software, which looks at the concurrency of transactions and looks at non-serial schedules and then tries to find out which schedules can be serialized. Okay, if a schedule can be serialized, it will be let through. A non-serial schedule will not be let through. Why? Because a schedule which cannot be serialized, that means not equivalent to a serial schedule, it leaves the database in something called inconsistent state. Okay? So it says here, everything on this page number 2, which you can see, where is page number 2? Here. Okay? So you can see here the statements. The objective of serializability is to find non-serial schedules that can be serialized and thus allow the transaction to execute concurrently without interfering with one another. That's the purpose. So if a set of transactions execute concurrently, we say they are non-serial schedule is correct if produces the same result as some serial schedule. Otherwise, we won't let it happen. This will not be correct. Okay? Now, what happens is when we talk about the condition of serializability, the order of read-write operations in a transaction will matter. What is the order? Okay? It will matter. Okay, so you don't need to copy this. If you want to copy it, but it's all in your handout. Okay, so now I want to show you here what are the cases when the order of the read-write statements matter. Okay, let me tell you, show you. It's in your handout too, so you don't have to worry about it. Okay, so if you are only reading, just like we were talking about seats from New York to on some flight to Moscow, and you're only reading, everybody just reading that, there's no interference. If you're just reading the database, what are the seats available, blah, 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 and it doesn't matter. If you are reading and writing different seats, somebody's looking at New York to Moscow, somebody looking at New York to the other person looking from New York to LA, New York to Paris, New York to London, and different people are looking at different things and they're doing read write, it won't matter because you are not looking at the same piece of data. Remember when you were little kids and you're playing games, when fight only happens when you're looking, each one of you want the same thing, right? Even in the same household, two kids want to play with the same thing, that's when the fight happens. That's where the problem is, okay? So this is what it is. When is they think these things will interfere? Well, let's say here, we are going to say one transaction reads something, then later on, some other transaction tries to write what it has read. Some other transaction. So this is, let's call this transaction T, and this is, let's call this transaction S. Oh no, one we call it T1, T2, right? What did we call? Okay, now we can't call it T. Come on. So let's call this transaction T V. Okay, so one transaction T, let's say read something, let's say A, some data A, and then the transaction V is just trying to write that data A. Okay? All right. Okay? Okay, guys? All right. Also, if it happens the other way around, it will be interference too. So even if it happens this way, okay, so if we go this way, there's the interference. So one transaction read A, and this one is writing it. So this one wrote, and now this is reading, okay? Same thing, okay? There will be interference. This order must be maintained. We cannot change the order here. If this is reading first and then this is writing, that's what will happen. If this is writing first and then this is reading, then this is the order will be there. And same situation happens when one is writing, and let's say this transaction T is writing, let's say A here, and then another transaction is also writing. So also writing. Right. Writing V. V is writing A also. So this is like when you're playing with your, sister or brother when you were little. So what is this equivalent to? This says, oh, one person is just looking at the toy, the other person is grabbing it. Okay. And this says one person grabbed it, now the other one is eyeing it. This says one person grabbed it, and now the other person is trying to grab it. Okay? Same toy. Okay. So that's where this interference will be. If everybody just looking at the toy, there's no interference. And if you looking at the car and the other person looking at a motorcycle, no problem. You can grab the motorcycle, the other person can grab the car. Remember that. This only happens if you are worried about the same piece of looking at the same database. Same database, same item. Okay? All right. So let's look at now. So look at the page 3. Now, the question is, we said that we are interested in those schedules which are legal non-serial schedules, okay? And they are equivalent to some serial schedule. The question is, how do we check it? Okay? I'm going to show you how to check it. Any question here? Any question? Arviganson, do you have any question? Okay. Okay. All right. So this whole thing is written. Please look at the bottom of page 2. Now I'm looking at the bottom of page 3. Okay. I'm going to show you the algorithm. How do we do this? Okay. So I'm going to erase this, guys. If there are any questions, just ask me. Okay. Oh, I want to repeat something. So you notice here, if you have T1 and T2, so first T1 goes, then T2, you have some answer. If T2 goes first, then T1, we get another answer. Now, if we have a totally non-serial schedule, the answer is completely going to be different. Okay. So for a second, okay, guys, we have S3, S1, S2, and S4. Please tell me what's the answer to this. S3 happens first. So what's the average first? It's going to be from R, what's the average?
1.5.
1.5. Thank you very much. And then from the other, from S, what's the average? Come on, we did it. It's going to be
1.5.
No, not 1.5.
Oh, sorry.
3.
3.
Why 3? Because now S1 and S2 went up. That means they changed R and S now. It became 2 and 4. So now we go with S4. It is going to give us 3. Now I could change this and still make it a legal schedule. Let me show you, and the answer will be different. So if I take this guy here, I go with the S1, then I go with S3, right? And S4, then S2. Is that schedule legal? Yes, because the order of steps of the transaction, first action is S1, second is S2. This comes first, this comes second. This one, second one, S3, S4. So what's the answer here? What's the answer here? First answer is going to be again, what's going to be? 1.5. And the second? We did S3 first. Okay. Second one is also, what's the answer for the second average? Same. Nothing going to change here. So what did we see here? Really, the conclusion is that if you have different schedules, okay, non-serial schedules, they are going to give you different answers. Now, what did we notice here, by the way, something? That here is a non-serial schedule, but its answer is equivalent to a serial schedule, which is T2, T1. Is that true or not? Are these exactly the same? The answer here and the answer here. Is the same or no?
Yes, it is.
Okay, so what do we see here? Here is a valid non-serial schedule, but it's equivalent to some serial schedule. We didn't guarantee whether it's equal to this one or this one. We cannot. But it doesn't matter which serial schedule it is, the database will be consistent. So this is what we are looking for. Those schedules, system will let them through. Those non-serial schedules, which are equivalent to some serial schedule execution, they will be let go because they will be called, valid or whatever you want to call them, schedules. Okay. So that's, if you look at here, we said that if a set of transactions execute concurrently, we say that the non-serial schedule is correct if it produces the same result as some serial schedule. So this will be correct. Okay. So there is some very big stuff in the part of the Dbms. What do you think it's called? What is it called? Concurrency control. I can have you write a Dbms which doesn't have anything to do with the concurrency control, maybe in a couple of semesters. But if you have to have concurrency control, that will take a lot more, another year, 2 maybe, depending on the package we are trying to do. This is the complicated stuff. Most complicated because they have to do also optimization. Okay, guys, let's show you now how you can test whether a given schedule like this can be serialized or not. That means its actions will be equivalent to some serial schedule like this. Okay, so let's look at that. Okay, we are going to do that quickly and then give you some examples. All right, so we got here. Okay. All right. Now this will be erased, okay? All right. So look on the bottom of page 3 in the middle. This is how we're going to do it, okay? So what do we do is, for each transaction, we're going to draw a node. So let's say we only have 2 transactions. We will draw 2 nodes. So let's say the first one is called T1 and the second one is called T2. Okay. Now we told you that here. Okay, so if you have this kind of situation where one transaction is reading something, oh boy, I had to put the number of the transaction here too. Let's call it T1. Let's call this T2. Okay. Okay, so transaction T1 is reading something and transaction T2 is writing something. Then this order must be maintained. You can't change the order. Therefore, we will draw an arrow in this graph from 1 to 2, from transaction 1 to 2. I repeat. So this graph is made up of nodes, and we call them arcs or links. If I draw join these two, okay? All right. If I, hey guys, get lost. There's too many ads. Okay. So if I have T1 read something and then T2 write the same thing, then T1 must come first, T2, okay? So let's look at this. All right. Now, here is a schedule which is given to me. Let me write it out. Oh my God. I'm going to write this out. Okay. So I'm going to write, what was that? Okay. Oh, okay. It was, okay. W. I'm just going to have to make it up, okay? Let me just make it up here. So let's say W is going to, okay, so this transaction 2, okay, is going to write, let's say B, okay? Then transaction 1 is going to read, let's say A, okay? Then transaction 1 is going to read, let's say B. Then transaction 2 is going to write A. Let me say A. Okay, guys, let's see now. This example is not in the handout, so let's just look at this example. Okay, first of all, what does the heck this means? Okay, what does this mean? What does this notation mean? Can I write it right here? That means, okay, transaction 2 writes data B. That's what it means, okay? So therefore, what will this mean? The next one, this one. What will that mean?
Transaction 1 is reading a data.
Yes, transaction 1, sorry, reads it. Everybody got it? Oh, come on. Okay, transaction 1 reads A, and the next one, this will be transaction 1 reads B. This is transaction 2 writes A. Okay, so the interference happens when one transaction is reading something, the other one's writing, or the other way around. One is writing, same thing, the other one's reading. After they have, okay, comes in sequence. This is time sequence. Oh, by the way, time moves in this direction. This is timeline. Okay, so time moves in this direction. Okay, so what do we see here? Let's look at this. This is transaction 2. Is there any other transaction doing something to 2, either reading or writing? Just look over here. This is transaction 2 reading B. It will interfere with something. Which transaction is doing that?
Transaction 1 is reading B.
Right here. Oh boy, let me get this. Right here. If I compare and this 2. So this tells us that 2 must come before 1. So the transaction, when we join these, the arrow will be in this direction because 2 has to happen before 1 because of this. Okay, now let's see this. Does this interfere with this? No, because this is working on B, this is working on A. Now, what about this? Does this interfere with this? No. A transaction 1 doesn't interfere with itself. A transaction only interferes with something, other transaction. Okay, this is reading A and this is writing A. So that tells us that transaction 1 has to come before transaction 2. Now, is it possible for transaction 2 to come first and 1 to come first? No. This is what we call a cycle in the graph. If there is a cycle in the graph, this particular schedule, which is non-serial, cannot be serialized. So the concurrency control will not let it go. They'll kill it. They will not let it go. Okay? Now, if this was something else, instead of say W, instead of being W, we said B, right? Let's say this happens to be, let's call this here. Let's say it's not A, but it is, give it a different, let's say it's a C, W2C. So it's a W2, it works on C. Now what happens? Well, now let's look at it. What happens now? Well, this comes first and then comes next. Therefore, 2 must happen before 1. And then this is itself. Anyway, read doesn't interfere, but nothing can interfere in single transaction. And then this is R1A. This is W2C. This is R1B. This is W2C. So that means this will not be there. So now it just says that T2 should come first and T1. That's it. So that is a serial schedule. And what's the schedule? Schedule is T2. T2 comes first. First T2, then T1. Oh, what happened there? Come on. Okay. First T2, then T1. That's the serial schedule. Let's look at one of the examples in the handout quickly. Let's look at that 1 minute. Okay. So what's the example in the handout here? Here. It says, number 2 I'm going to look at, okay? So what is it? R1A in parentheses A. The next one is, oh, by the way, each one of them is a, what you call, valid SQL expression. So there is going to be a semicolon at the end of each, okay? W1 in parentheses B, semicolon. Then we have R2B, semicolon. W2C, R3C. And then W3A. And semicolon. Okay, this is right on your handout. Question number 2, examples. Okay, so let's see what's happening here. Now, how many transactions are here? 1. What did I do here? This was, oh, this is supposed to be closed here. Okay, so we got transaction 1, reading A, writing 1, writing B, reading 2, reading B, 2 reading C, 3 reading C, and 4 writing A. Okay, so how many transactions we have? 1, 2, 3. Okay, so let's make here 3 circles. 1, 2, and 3. Come on. Okay. So this one, let me write it in here. I'll write here T1. And I'll write here T2. And write here T3. So you make 3 circles, number of circles, each corresponds to 1 transaction. You do that, okay? That's what we did here. We got 3 transactions, 1, 2, and number 3, this, and this. Now, let's see what happens here. Now, look at here. Transaction 1 is reading A. Is there any other transaction doing something with A? Well, this is doing with B, this is doing with B, this is doing with C. Ah, here it is. Here is another transaction. So this transaction is reading and this transaction is writing. Therefore, this order must be maintained. So there should be a line, arrow from 1 to 3. Repeat. If one transaction is reading A, another one is writing A, they will interfere. Therefore, this order of read-write must be maintained. Okay, let's look at the next one. So this, okay, this one is writing B, and look at this. This is 1 writing B, 2 reading B. So 1 must come before 2. Okay, so we can draw that arrow right here. 1 must come before, let's make it blue, that is this and this. Okay, let's keep on. This is 1 doing something with B. This is doing with B, this is doing with C, C doesn't work. Okay, so let's start with R2B. This is doing something with B. Is this doing with B? No. This doing with B? No. This doing with B? No. Now let's start with this guy. This is W2C. So 2 is working with C. Is there anything else working with C? Oh, right here. 3, this is writing, this is reading. So this is the other way here. If one transaction writing something and the other one is reading the same thing, this order must be maintained. So 2 must come first, 3 come later. 2 first, 3 later. Let's keep on going. This is C, this is also A. Doesn't work. Now let's look at this one. This is C, this is it. This is it. So remember, time is moving in this direction, so you can't go back. You are always going forward in time. Now what happens here? T1 must come first, right? Then either it could be T3 or it could be T4. There's no cycle here. Look at this. This says T1 comes, then T2. This says T2 and then T3. And this says T1 before T3. So look at here. 1, down, down, but this is against. This is not a cycle. If this was a cycle, then there will be a problem. So here is a schedule. What is the schedule here? Well, T1 can have first. T1 can be first. T1 can be first. Then we can have, go to T2. Then we can have T3. And that will satisfy this. Is there any other schedule? Well, look at this. How about this? How about this? First T1, then T3, and then T2. Does that work? Well, let's see. In here, T1 should be first, then T3. T1 is first, then T3. T1 first, then T2. T1 first, then T2. Over here, again, T1 first, then T3. T1 first, then T2. T1 first, then T2. Both these are valid serial schedules. Does everybody understand that? Why? Why these two are valid, this and this, from this picture? Okay, what does the serial schedule mean? That first one transaction does finish, and then the next one finishes, then the next one finishes. Okay? So what we saw here, that according to this rule here, first T1 comes, then T3, or first T1 comes, then T2, or T2, and then T3. Well, all these orders are maintained. T1 first, then T3, T1 first, then T2, T2 first, and then T3. Okay. Now, who's going to tell me whether this is right or wrong according to that?
Yeah, that's what my question was, because T3 is after T2 in both directions, like when we see the graph, whatever.
Okay, so therefore, this one is wrong.
Okay.
This one is wrong. It doesn't satisfy these conditions. It satisfies these two red conditions, not the blue one. Blue one clearly tells us first T1, then T2, then T3. We see it right here. Right here. Because if you follow this, then there'll always be T1 first and T3 later. You can't follow this way. How can you follow this way? This is no good. This is T1 first, then T3, and then this is, no, this says T2 first. Okay, let's look at the other question, 1 minute. The first one on the top. Okay, I'm not going to, no, I will do the next one. Okay, W3, let me write that down here. Let me do this one. We got time, I'm going to do this fast. Okay, everybody has the handout?
Yes.
Okay, look at question number 3. How many transactions are there? 1, 2, and 3. That's it. So we will have same kind of picture here. Let's write it down here. 1, 2, and 3. It doesn't matter where you put 1 and where you put 3. Let me put here transaction 2. And let me put here transaction 3. And let me put here transaction 1. It doesn't matter where you put it. Okay, now look at the graph. Okay, not a graph. Look at the line given to you. First is W3. W3, that is transaction 3 reading A. Right next to it is R1A. What does that mean? Number transaction 1 is writing A. So therefore, it says 3 must come before. 3 must come before
1.
1. Let's keep on doing. And then anybody else has A? No, nothing. So let's forget it. R1A. Anybody else has A? No. A doesn't. Nobody else is doing anything with A. Next one is B. W1 that works with B. Oh, well, one right next to it R2B. So what is the mean? What does that mean? That one must come before
1 and then 2.
Then 2. Let's keep on going. Oh, there is no other B. Okay. Now we have only C. W2C and R3C. What does that mean? 2 must come before?
2 must come before 3.
Right here. 2 must come before 3. Now we got a problem. There's no way. We can't do anything. That's right, Victor. There's a cycle. There's no way we can do any serial schedule. Here says this must come first. And here we have this come first. So let's say you write down T1, T2, T3. What happens? Is that a good schedule? You write down T1, T2, T3. T1, T2, T3. Does it make any sense? Well, 2 should come before 3. That's good. 2 comes before 3. Here it says 1 should come before 2. Well, 1 comes before 2. And this says here 3 should come before 1. Is 3 coming before 1?
No.
No. Can we say T1, T3, T1? Can we say anything? No, you cannot. T1, T3, T2. Okay. Now what? Well, 1 should come before 2. Well, 1 is coming before 2. No problem. 2 should come before 3. Oh, that's no good. Okay. So you know that there are 6 possible what you call serial schedules, but none of them will work because of this cycle. Because cycle tells you that you cannot satisfy this. This cannot be satisfied. It can only be satisfied in this case. See this? This is against it, so it's not a cycle. One of them, 2 of them can go in the same direction, but the one of them has to be in the opposite direction. Okay? All right? So this schedule is not serializable. So you can try to do question number 1, 4, and 5, and you can do that as homework and get credit for it. Any questions on that? Let me explain that also. So when you look at question number 1, what's going to happen? I can even do for you quickly. Question number 1, what's going to happen? Let's erase this. Question 1 has what? It has
3 transactions.
how many?
3.
Okay, 3. So let's write here T3. And let's write there T2, and let's write here T1. So I'm just going to do this as you can only have to do 2, okay? All right, let's see that. So R2 is A. What's the next A happens? What's that happens?
To right to A.
W2A.
Yes.
So that's nothing, no problem, right? Because transaction 2 cannot interfere with itself. Let's say you're trying to buy a seat. You have to first read it. Then you can update it. Yes?
Yes.
You're not interfering with anybody. Remember that. Okay. Go on. Then
T3.
R3. That's also just reading it. Nothing.
Yeah.
Reading doesn't interfere with reading. Keep on going. W1B. Well, oh, we have W3A. So that means 2 must come before
3.
2 must come before 3. Keep on going. Okay. So what we have? 2 must come before 3. Okay. Then is there any other A?
No.
Oh, there's another A.
Where?
So W2A and W3A. That also means 2 must come before 3. So that's another arrow here, but that doesn't change anything. Is there any other A? No. Now start with R3A. R3A and W3A, they will not interfere with each other. Okay, forget it. Then we have W1B. Oh, wait a minute. R3A and W3A, right? They cannot interfere. Okay. Then we have W1B and R2B. So that means one must come before
3. No. What?
2. Right?
Yes. One should come.
W1B and R2B. And then you have W1B and W2B. What does that mean? One must come before
2.
2. Okay, this is it. So your schedule is 1, 2, 3. T1, T2, T3. That's it. Right here. There's no cycle. No cycle. Therefore, it is serializable. Okay? It's finished. All right. So you can do question number 4 and 5 as homework. Okay? Now, I'm going to look at all the appointments you guys want to make. Send me what you have done, and I will make the appointments. We will have to make the appointments for this weekend and maybe including sometimes tomorrow also. Okay? So please do it right now. It's not going to be any more time left. Okay?
Okay.
Because the exam, so on Thursday, we will have a review. Okay? Tuesday, we will finish up this lecture, and Thursday, we will have a review. And then the next week, after that, on 22nd, which is Tuesday, it will be your exam. So now let me tell you about the review. I'm not going to start going over everything from beginning to the end. No, I will answer questions. So please study on the weekend and then come up with the questions. Write them down and ask me questions. Okay, please. So I'm giving you this as the homework, question number 4 and 5. Okay, from the sheet. Everybody, homework. Question number 4 and 5, I will put it on, okay? So question 4 and 5.
And when is this going to be due?
It will be due sometime next week. Let's say Wednesday.
Okay.
Or I might change them too. I'll give you something. You can do these two, and I might add 2 more.
Okay.
Okay. So it'll be question 4 and 5. But my suggestion to you guys is, please go over even the ones I went over here first. Go over them also. Plus some more. I'm going to write them down, okay? All right. Anybody has any question? I am still here, okay?
And can I ask a question, please?
I will be here another half an hour.
Okay.
How do we make the appointment?
The appointment will be made by me. So what you do is you are going to send me an email. And first of all, you have to have done what I told you have to do. Okay?
Okay.
As a matter of fact, I changed the submission to tomorrow. The reason for that was that I forgot to write there that you have to have supertypes and subtypes and their relationships or the supertype subtypes. Okay? Because otherwise, this is a EERD, not ERD. Otherwise, it won't work. Okay? So I also allow you to resubmit it. You can resubmit it.